Hi dear students, we were discussing the topics related to electrostatic potential and capacitance, and today in this video let us discuss the concepts of equipotential surface. As the name itself suggests, as once again just observe that equipotential surface. So any surface on which the value of electric potential is the same at all the points, such a surface can be considered as a equipotential surface. So ಯಾವ surface ಆದರೂ ಆಗಲಿ, if the value of that potential on that surface remains same at all the points, then it is said to be equipotential surface. Yes, observe the definition there. The surface with a constant value of potential at all points on the surface is called equipotential surface. Yes, we have some of the properties of equipotential surface. The first one, potential difference between 2 points on the equipotential surface is 0, because 2 points lying on the equipotential surface, so potential difference will be 0. They have same potential. Therefore, no work is required to move a test charge from one equipotential, that means from one point to another point on the equipotential surface, because potential remains same. As we all know that V is equals to W by Q. If V is, that is potential difference is 0, then W will be also considered to be 0. Work is not required to move a point charge on equipotential surface. The second property, electric field is normal to the equipotential surface. So the field lines are normal to that equipotential surface. The third property of equipotential surface, two equipotential surfaces never intersect each other. So we can discuss them in detail in next slides. Yes, here we are observing the representations of equipotential surfaces for that point charge and for a pair of like charges, as well as for unlike charges and equipotential surfaces in case of that uniform electric field. So in general, first try to understand the concepts of that study about equipotential surfaces in detail. Yes, here we are observing a point charge that is positively charged. Because of that positive polarity, it will produce the electric field radially outwards in all directions. That is represented by those lines. Now, that source charge has its influence in all directions. Potential is associated with that amount of work done in bringing a test charge. Let us consider I am going to bring a test charge from infinity to given point. In the same way, I am bringing the test charge from infinity to this point in this direction, and I am going to bring the test charge from infinity to this given point in this direction. In any direction we can bring the test charge to a given point. So point lies here, point lies here, the third point lies here. So the amount of work done will be same. Why the amount of work done remains same means, if we observe the distance of all the 3 points, this is the first point, right? So this is the distance of second point, and this is the distance of third point. So the distance is same for all the 3 points. The distance is same from the source charge, and that test charge remains the same. And we already know that the potential varies inversely with respect to the distance. That means potential depends on distance. If distance is same, then the potential also remains same. Thus, for all the points on this sphere, the potential remains same, hence it is called equipotential surface. And we are assigning some value as potential V3 on that sphere. The value remains same at all the points. In the same way, we can observe one more concentric sphere with some different potential V2, but at all the points on that sphere the value of the potential remains same, and we can have one more representation of the concentric sphere with a potential value V1. In the picture it is clear that the electric field lines are normal to the equipotential surfaces. It is one of the property, and the field lines are radially outwards because of positive polarity. The equipotential surfaces are a series of concentric spheres. They are series of concentric spheres, and this is representation for unit, that is test charge, point charge. Different spheres corresponds to different values of V, as we are assigned the values V1, V2, V3, and we can understand here V1 must be greater than V2 must be greater than V3, and it is very simple. We can relate that with respect to the distance. As the distance is more, the potential will be less. If distance is less, the potential will be more. As we have the first concentric sphere, that is potential V1, so potential value is more, and V3 it is somewhat far away from that source charge, so its potential is less. So V1 is greater than, V2 is greater than V3. Yes, here we can observe that clearly, the values of potential. The electric field lines we have, and the dotted spherical surfaces represents the equipotential surfaces. The outermost spherical surface, it is having the value that is 10 volt, next to that 20, and the last one has 30 volt. As we are observing that 30 volt, that means which is very near to the source charge, has more potential because work required to be done is more because of more repulsive force. So this is in case of the point charge. Now yes, here also we are representing the equipotential surfaces, that in case of the unlike charges, we can observe that unlike charges, so one must be negative, the other one must be positive. So these unlike charges, as we know that they are going to experience some attractive force, so they are close together in the region between the two charges. The region between the two charges, they are seems to be closer. This indicates the strong electric field between the two charges. This is a representation of equipotential surfaces for system of two unlike charges. Yes, this is the representation of equipotential surface due to system of like charges. System of two like charges. As they are experiencing the repulsive force, they are far apart in the region between the two charges, and this indicates the weak electric field. This is a representation for like charges, equipotential surfaces for like charges. Yes, in this picture we are observing the representation of equipotential surface in case of uniform electric field. How we can say it is uniform electric field? Because the field lines are in same direction, they are parallel to each other, and the distance remains same, equidistant. And the equipotential surfaces, that means the value of potential at all the points on this surface remains the same. In the same way, all the points on this surface will have same potential value. So this is the representation of equipotential surface in case of uniform electric field.